So today we have a geometrical problem. The diagram is on the screen with all the given details. Now the point to be noted over here is that all the contact points between the circles and the line segment are tangent points. So using all this given data and arrangement of this diagram, the question over here is to find the value of x upon y. So this is Anmol Mishra, and now let us see the solution. How can we find the value of this particular fraction? So first of all, we will utilize the fact that all the contact points between the line segments and the circle are tangent points. So look at this smaller circle of radius 2 units. So here we can see that the circle is tangent at 3 points. So for one of the point, the radius has already been drawn, and as per the theorem, the point of contact would have an angle 90 degree. Similarly, I will draw radius to these two tangent points also. So the angle formed over there would be 90 degree. Okay. Now what if I will draw a line segment from the point B to the center of the circle? Let the center of the circle be point O and center of the bigger circle be P. So if I draw a line segment joining the points B and O, we can see that these two triangles are congruent because of right angle hypotenuse side. Right angle, common hypotenuse, and these two sides ultimately the radius, therefore equal. So these two triangles are congruent, therefore these two angles become equal. So if these two angles become equal, let that be a value theta. So what we can see that the complete angle becomes 2 times theta, and that is 60 degree. Why 60 degree? It was given that the complete triangle ABC is an equilateral triangle. So in equilateral triangle, all the angles are 60 degree. Therefore 2 theta is 60 degree. We get theta as equals to 30 degree. So let us replace theta as equals to 30 degree over here. The same thing can be done for this bigger circle also. Radius to these 3 tangent points, so the angle over there would be 90 degree. Okay, and I will draw a line segment from P to C, again 60 degree. These two triangles congruent, therefore the angle gets bisected as 30 degree and 30 degree. Okay, now carefully look in this right angle triangles. We can see that we have right angle triangle first of all, and one of the angle is 30 degree and height is equals to 2 in this triangle and 3 in this triangle. So we can easily take the ratio of tan 30 degree. So in the smaller triangle, tan 30 degree would be equals to height, that is 2, and the base. So let this intersection point be M, and that would be equals to N. So in this triangle BOM, the value for tan 30 would be 2 upon BM, and that would be 1 upon square root of 3, that is tan 30. So simplifying this thing will give me BM as equals to 2 square root of 3. Okay. Similarly, in this bigger triangle, that is the triangle PNC, the value for tan 30 degree would be equals to 3 upon the base, that is NC, and this thing would also be equals to 1 upon square root of 3, that's the value for tan 30 degree. So cross multiplying this will give me the value for NC as 3 square root of 3. So here we have got the value for NC, and previously we were having the value for BM. Now remember that these two triangles were congruent, rest of the things between them become equal. So if the length of BM is equals to 2 square root of 3, therefore the length from here to here would also be equals to 2 square root of 3. Similarly, on the other side, if the length of NC is equals to 3 square root of 3, and as this and this triangles were congruent, the distance from here to here would also be equals to 3 square root of 3. Now recall that the triangle ABC is an equilateral triangle. Therefore, all the 3 sides of equilateral triangle are equal. So look carefully that the length of BC is ultimately x plus y. So x plus y is the length of one side of this equilateral triangle. This means all the 3 sides would have a length x plus y. Now carefully see over here, the length from A to B is x plus y. Let this point be K and let this point be L over there. So look carefully that the length from A to B is x plus y. The length of K to B is 2 square root of 3. Therefore the ultimate length of K to A would be equals to x plus y minus 2 square root of 3. So let me just remove this, and over here we would have x plus y minus 2 square root of 3. Okay. Now the same thing we will do on the right hand side. So the length from A to C would also be equals to x plus y. The length from L to C is 3 square root of 3. Therefore the length of AL would become x plus y minus 3 square root of 3. Okay. Now carefully look over here. If I will draw a line segment joining the points A and O, again we can see that these two triangles will be congruent. Right angle, common hypotenuse and the sides are equal, that are ultimately the radius for the smaller square. So let this point over here be the point E and let this point be the point F. Okay, so as the triangle OAK is congruent to the triangle OAE, the length of AK would be equals to length of AE. So let me just write it over there. So here we have got the length of AE as equals to x plus y minus 2 square root of 3. Now similarly, if I will draw a line segment joining the points A and P, these two triangles will become congruent because of right angle hypotenuse side. So the length of AL would be equals to the length of AF. So AL equals to AF, and that would be equals to x plus y minus 3 square root of 3. Okay. Now what if I subtract like this way, AE minus AF? So the left hand side subtracted equals to the right hand side subtracted. So x plus y minus 2 root 3 minus x plus y minus 3 root 3. And if we will simplify this thing, what we'll finally get is square root of 3. So this is the value for AE minus AF. Now carefully look in this diagram. The complete length AE is from here to here. Some part is AF. So AE minus AF is ultimately EF. So here we have got the length of EF. Now let us do the further calculation. Now what we have just got is this much length, that is of EF. The length of OE is radius equals to 2. The length of PF is the radius of the bigger circle, length is equals to 3. So the ultimate formation form over there. So I'm just drawing whatever is required. So O to E like this, E to F, and then F to P. O, E, F, P. The length of OE is 2, the length of PF is 3, and the length of FE is square root of 3 that we have just got. The angle over here are 90 degrees. Now the same thing can be just drawn like this, this, and this. Okay, 2, square root of 3, and 3. The angles are 90 degrees. Now the base can be just extended in a straight line. So here if I will draw a line segment joining the points O and P, the same thing can be drawn like this to here. Okay, so what I have done till now is I have extended the base. Now as we can see that these two lines are parallel, so the perpendicular distance between parallel line is always equal. So if I draw a perpendicular from this point to the base, so this length would also be square root of 3 because one of the perpendicular is already having a length. So here we form a rectangle. So as the breadths are equal, the lengths would also be equal. So from here to here the distance would be 3. Now let me just remove this thing from here. So after doing some of the shiftings, we have got the lengths over here. Now look carefully, the base would have a complete length 2 plus 3 that is equals to 5. So in a right angle triangle the base is 5, the height is square root of 3. Therefore the hypotenuse would be square root of 28. Now recall that the yellow line is ultimately this length, that is from O to P. So here what we have is the ultimate distance of OP, that is the distance between the centers of the two circles, and that is square root of 28. Keep this thing as it is, that is why I am writing it in a bright color, because this is required many times. So here was the first part of the solution, where we have got the length of OP as equals to square root of 28. Now let us see the second part in a second diagram. So here I have taken the second diagram and the labelings will be the same to same. The point A, B, C, D, M, N. Okay, the length of BD was X, the length of DC was equals to Y. And now we will put some details that we got from the first part. The length of BM as 2 square root of 3, the length of NC as equals to 3 square root of 3. The radius is 3 and this radius is 2, that was given data. Okay, now carefully look over here. The length of BD is X, the length of BM is 2 square root of 3. Therefore the length of MD would be equals to X minus 2 square root of 3, longer minus the shorter. Similarly on the other side, the length of DC is Y, the length of NC is 3 square root of 3. Therefore the length of DN would be equals to Y minus 3 square root of 3. So if I just remove this thing from here, so what we currently have is length of MD and the length of DN. So if I just add this both, what I get is the complete length of MN, and that would be equals to X plus Y minus 5 square root of 3, adding the right hand side of this equation. Okay, so here we have got the length of MN. Now recall that the angle M and angle N were 90 degrees because they were the tangent point angles. Okay, now I will draw a perpendicular from the point O to the line segment PN. So here we have formed a rectangle. So in rectangle, opposite sides are equal. So if length of OM is 2, so the length from here to here would be 2. The complete length is equals to 3. Therefore, the remaining length, that is from the point P, let this point be K. So from P to K, the length would be equals to 1. Okay. The length of OK would be equals to length of MN, that we have got as x plus y minus 5 square root of 3. So here we have formed again a right angle triangle like this way. The base is having a length x plus y minus 5 square root of 3. The height is having a length 1. Here is the 90 degree. So by applying the Pythagoras theorem, the length of the hypotenuse would be square root of x plus y minus 5 root 3, the complete square, plus 1 square, and that length is ultimately O to P. So again you can see that we have got the distance for OP. So let me just write it over there. So here in the second part of the solution, we have got the length of OP as square root of x plus y minus 5 square root of 3, the complete square, plus 1 square, all in square root. So in the second part of the solution, we have got the length of OP again. So till now we have done two parts of the solution, and in both the parts the final conclusion was the length of OP. Now let us do the third part, and here I have taken the same diagram. I will do the same labeling. The point A, B, C, M, D and N. The center of the smaller circle was O, the center of bigger was P, this length 3, this length 2. Okay. Now the angle M and N were 90 degree because they were tangent points. Now I will draw the radius to the other remaining tangent points also. Okay. In the first case, you can see that we have utilized the tangency from this side by doing this all things. Now in the third case that we are currently doing, we'll do the tangential utilization from inside. Okay. So here if I will draw a line segment from point O to D, and in the other triangle I will draw a line segment from D to P. Okay. Now recall that we were having the length of MD from the second part, that was x minus 2 square root of 3. Similarly, the length of DN was y minus 3 square root of 3. So here also I will put the same thing. MD is having a length x minus 2 square root of 3. Length of DN is y minus 3 square root of 3. Okay. Okay, now I'm just drawing something outside because I need space over there. So here are the two perpendiculars. Here is the radius from the first line. Here is that slant line. Here is the radius from this other triangle, perpendicular that is. Okay. And here I have drawn a line something like this, over there like this. O, M, D, P, N, and let this point be the point F. This was already F labeled in the first part, remember. Okay. So the same thing I have drawn over here. And these two angles for 90 degree also. Okay, this length is 2, this length is 3. The length of MD we have, that is x minus 2 square root of 3. The length of DN is y minus 3 square root of 3. Okay. Now carefully look that these two triangles are congruent because of right angle hypotenuse side. Right angle, common hypotenuse, and the sides are ultimately the radius. Similarly, in this triangle, the radius are equal. The right angle triangle is present and the common hypotenuse, again similar by right angle hypotenuse side. So two triangles congruent, rest of the things between them become equal. So here in the first case, these two angles become equal, let it be equals to theta. In the other case, these two angles become equal and let it be equals to alpha. Now carefully observe that all these angles are in a straight line. Therefore 2 times theta plus 2 times alpha is 180 degree. Therefore the value for theta plus alpha is 90 degree. So theta plus alpha is forming over here. So this addition would be 90 degree. Okay. Now look in this right angle triangle, that is the right angle triangle OMD. The height is 2, the base is x minus 2 square root of 3. So by applying the Pythagoras theorem, the length of OD would be square root of 4 plus x minus 2 square root of 3, the complete square. Similarly, here we have a right angle triangle. The height is 3, the base is y minus 3 square root of 3. Therefore, the length of PD would be equals to square root of 3 square 9 plus the base square, that is y minus 3 square root of 3, the complete square. Okay. Now carefully see that the lengths that we have just got, OD and PD, is the height and base, like this way, O, D and P. So O, D and P, here is the 90 degree. The length of OD we have, and we also have the length of PD. So if I draw the hypotenuse from O to P, a right angle triangle, we have the height, we have the base. Applying the Pythagoras theorem will give me OP. So using OD and PD and the angle D as 90 degree, we get the length of OP as equals to square root of 4 plus x minus 2 square root of 3 the complete square plus 9 plus y minus 3 square root of 3 the complete square. Okay, so here we have got the value for OP, and remember that this is the third time we got the length of OP. So here we have done 3 parts of the solution, and the final conclusion in all of them was the length of OP. So now let us compare these equations and try to get our answer. So first of all, I will compare the first equation with the second equation. So in the first equation, the length of OP is square root of 28. Therefore, the length of OP square would be 28. In the second equation, the length of OP square would be x plus y minus 5 root 3, the complete square plus 1 square. So now I can compare the right hand side of these two equations. So I will get 28 equals to x plus y minus 5 root 3, the complete square plus 1 square, that is 1. Now 28 minus 1 becomes 27. I will take square root on both of the side. So on the right hand side, square and square root got cancelled out. On the left hand side, square root of 27 is 3 square root of 3, and that is x plus y minus 5 root 3. So simplifying this thing will give me the value for x plus y as 8 square root of 3. So here you can see that we got the value for x plus y as 8 root 3, that is ultimately the side length of the equilateral triangle. So you may notice that if the circles are arranged in this pattern with some radius, we can even find the side length of the equilateral triangle. And using this data, you can even find many things like the area of the triangle, and many more questions can be just formed. Okay, now here the question was to find x upon y, so we'll see that only. So here I compared the first equation with the second equation to get the value for x plus y. Now I will compare the second equation with the third equation. So second equation, the value for OP square was this thing. On the third equation, the value for OP square would be equals to 4 plus 9, that's 13, plus x minus 2 root 3 the complete square plus y minus 3 root 3 the complete square. So here we again have the value for OP square. So in these two equations, we can compare their right hand side. So what we get is x plus y minus 5 square root of 3 the complete square plus 1 equals to 13 plus x minus 2 square root of 3 the complete square plus y minus 3 square root of 3 the complete square. So now we can easily simplify this thing by opening these brackets using algebraic identities and cancelling out the like terms or addition and subtracting them. So what we will finally get is xy plus 12 equals to 3 square root of 3 times x plus 2 square root of 3 times y. So comparing this to equation, we got this thing. Now remember that we have earlier got the value for x plus y. So from this equation, the value for y can be 8 square root of 3 minus x. So here we have the value for y in terms of x. So the y in this equation that is present over here and here can be replaced with this value. So x into 8 square root of 3 minus x plus 12 equals to 3 square root of 3 times x plus 2 square root of 3 into 8 square root of 3 minus x. And when you will open the brackets and simplify this thing, we'll finally get an equation like x square minus 7 root 3 times x plus 36 equals to 0. So opening the brackets over here and simplifying the like terms and all the things will give us this final result. So here we have a simple quadratic equation. So let us simplify this thing using the quadratic formula. So x would be equals to 7 square root of 3 plus and minus square root of 7 square root of 3 the whole square means 49 into 3 minus 4 into 36 divided by 2. Now 4 into 36 can be just factored out and written as 4 into 12 into 3. Now 4 into 12 becomes 48 and into 3 as it is. So 48 into 3. Now 49 into 3 minus 48 into 3, I can simply take 3 common, and inside the bracket what I will have is 49 minus 48, which simply equals to 1. So what is finally remaining is square root of 3. So x equals to 7 root 3 plus and minus square root of 3. So from here two cases, 7 root 3 plus root 3 upon 2, or else 7 root 3 minus root 3 upon 2. These are like terms, so finally we'll get x as equals to 4 square root of 3 or else 3 square root of 3. Okay. Now remember the first equation where y was equals to 8 root 3 minus x. So putting these two values for x, we will get y as equals to 4 root 3 or else 5 root 3. Okay. So now we can see that for x equals to 4 root 3, we got y as 4 root 3. For x equals to 3 root 3, we got y as equals to 5 root 3. Now as the diagram was arranged, we can easily say that x was smaller than y. Because there was a slant line like this way, the base was like this. So this distance has to be smaller than this distance. So x is smaller than y. So x equals to y equals to 4 root 3 cannot be taken. So what we get is x equals to 3 root 3, and for this particular case y equals to 5 root 3. Now remember, the question was to find the ratio of x upon y. So I can simply divide these two equations. So what I will get is x upon y equals to 3 upon 5, and that's the answer that we were looking for. So here you can see that if in an equilateral triangle two circles are arranged in the specific pattern, so using the radius of the circles you can get the ratio of x upon y. And I think the more important question would be to find the value for x plus y, that is the side of the equilateral triangle. And here the radius was 2 and 3, therefore we got x plus y as 8 square root of 3. This thing was also an interesting task. Okay, so this was my way to solve this particular question. If you have any other method other than this, do comment below, and if it's hard to comment you can email me, or else you can send it to me on my Instagram. The link is in the description.